Welcome to the Real Python Podcast. This is episode 265. What are your choices for hosting your Python applications or scripts? What are the advantages of a platform as a service, container-based hosts, or setting up a virtual machine? Christopher Trudeau is back on the show this week, bringing another batch of PyCoder's Weekly articles and projects. We discuss a recent article about hosting Python applications. The piece digs into the differences between using containers or platform-provided tools to automatically configure your project. We also cover an older article listing several free hosting options for smaller projects or Python scripts. The Python documentary premiered last week, and we provide a synopsis and our thoughts. Following a similar theme, we cover our recent Code Conversation video course, which explores the history of Python versions and features added across the releases. We also share several other articles and projects from the Python community, including a news roundup, Regex Affordances, 4 different ways to speed up your code, a Python-based music library manager, a tool to visualize the structure of your data in Python, and a project for exploring color science in Python. This episode is sponsored by InfluxData. Stuck with slow, time series data queries? It's not your code, it's your database. Traditional databases weren't built for timestamped data. InfluxDB was. Handle millions of data points per second, while competitors wait for dashboards to load. When you use the right tool for time series data, everything becomes faster, simpler, and more effective. Stop waiting. Start building at influxdata.com/realpython. All right, let's get started. The Real Python Podcast is a weekly conversation about using Python in the real world. My name is Christopher Bailey, your host. Each week, we feature interviews with experts in the community and discussions about the topics, articles, and courses found at realpython.com. After the podcast, join us and learn real-world Python skills with a community of experts at realpython.com. Hey, Christopher. Welcome back.
Hey there.
All right, so we have a bunch of fun stuff to talk about this week, a topic/discussion, a couple news items, a couple ones you just kind of handed me right as we started to begin.
Breaking news.
Yeah, totally.
Nothing's breaking news when you record weeks ahead of release, but breaking
Exactly. It depends how tied to the news you are. So
Yes.
Maybe it's a refresh from you.
It's last minute for us. Yes.
Yeah, exactly. All right, you ready to dig in?
Sure. First off is PEP 728, which is titled TypedDict with typed extra items. So inside the typing module is a class called TypedDict, which is structured similar to a data class in that you inherit from it and declare its attributes. The result is a dictionary, though, instead, but you get to use type checking on its values. So the PEP specifies 2 new features. The first is a parameter at creation that indicates the types of non-specific attributes. So for example, extra items equals bool means that the TypedDict can support attributes that aren't explicitly given as long as they're typed Boolean. So it's kind of like a catch-all of typing for keys that you haven't specified. And then the second new parameter is closed, which when you set it to true, explicitly denies the addition of non-specified attributes, even with inheritance, essentially stopping you from doing that thing I just described. So PEP 728 has been marked as accepted, and it's currently targeted for Python 3.15. The next bit of news is a security release for Django. Versions 5.2.6, 5.1.12, and 4.2.24 are out. This is a fix for a potential SQL injection vulnerability with the filtered relation class. It's high severity due to its nature, but you're only exposed in a very particular case when you're using query set, annotator, alias, and a keywords dict. So if you're mucking with that stuff, go get your new version on. And then speaking of typing, last, the annual Type System and Tooling Survey is up. This is run jointly by the PyRefly folks at Meta and PyCharm folks at JetBrains. So go fill in the survey and tell them how fantastic typing is, because somebody's got to counter the data I just filled in.
Oh, yeah. Kind of on a related news, It'll be interesting to see how DjangoCon US goes. They're meeting in Chicago this coming week. I hope they have a good conference. It was fun to catch up with a lot of the Django people in Ireland this year with you. That was cool. So,
Yeah.
All right. So first topic, thought it'd be nice to talk a little bit about two things that are related. One is the Python documentary just came out on YouTube. It's free. So if you'd like to check it out, I'm going to give you some detail and we'll kind of give some opinions and some things that we thought were useful about it. But in some parallel thinking, Christopher and I created a video course on real Python that we've had this sort of catch-all thing called a code conversation that allows us to do things that are not based upon written tutorials. And we created one called a history of Python versions and features. And so I want to talk about both of them a little bit and some connections between the two. So the Python documentary, I didn't notice the subtitle of it, which makes a little more sense now, but it's Python : the documentary pipe an origin story. And so that helps a little bit because I felt like it did end kind of abruptly, which makes sense. You don't want it to go on forever, but it's just under 90 minutes. It covers the background of Guido coming up with the language on a holiday break and sharing it with some colleagues. It really digs into those early days of sort of finding traction with developers. The production company is interesting. They're called Cult Repo. They formerly were named Honeypot. Not sure about these names, but generally the branding is telling the stories behind open source software. And they do a bunch of these. So they kind of get funding from different organizations to go in and tell these stories about open source. They've done one for like Node, Angular, Ruby on Rails, and other sort of tools and stuff that are kind of related. I feel like they capture a lot of footage for doing these kind of larger projects like this Python one. And so there's like additional little side stories you can kind of dive into about a variety of the things that kind of came up in this story, things like Dropbox. So one of the things that I liked about it was learning more about the early players. I didn't know how often that Guido kind of moved from company to company and in that keeping the language going. I had some conversations with Paul Everett, who is featured in the doc, that gave some additional background about some of those moves, especially around this sort of web-based development that was tied to some of it. I was not familiar with the Corporation for National Research Initiatives, which was very interesting to kind of learn. That was like one of these first places that Python was at home at. They talked about the concept of the benevolent dictator for life and that terminology and how Guido sort of fit into that role. It also digs into a lot of the early scientific computing. I had Travis Oliphant on recently. If you're a regular listener, you probably have checked that out. And there's so many of the things that he worked on that definitely get mentioned. It was nice to see other big names that are in the software world talk about their use of Python. Often people ask, like, well, what is Python used for? And we've done some courses and some other resources at Real Python to describe that. But often, it's like, why should I care about Python? And it's like, okay, well, Dropbox I mentioned a minute ago, which is interesting because it's another place that Guido worked for a while. Instagram, Blender, I wasn't aware of, but it talked a little bit about why they chose Python. And partly they picked it as their scripting tool, partly because it was open source. And so it was neat to see the people that are involved with those organizations or members of those teams. There is a whole background about the PSF and this sort of need to, again, since Python was moving from company to company to company, what sort of ownership would that corporation or company want in that process? And so to create this separate organization that is sort of in control and has the interest behind keeping Python going as a language and the ownership not being tied, again, keeping it open. Some of the first gatherings that eventually became PyCon. There's a bunch of stuff about data science inside there. The doc was financed by Anaconda and Open Teams and QuantSight. So there's some featured player from these organizations. There's moments of drama, like any documentary, especially the moving from Python 2 to 3. Armin Ronacher is featured in there as a person who's had strong feelings, let's say, about that transition. I had him on the show very early on in our existence as a podcast to talk about 10 years of Flask. And at the time, he had kind of moved on to work in Rust. And it's interesting seeing him come back. to Python a little more fully lately. There's also the big drama around the walrus operator and eventually Guido stepping down as BDFL, which led to the creation of the steering council. And I've talked to Brett Cannon a few times about that. He was on the first versions of the steering council. In fact, it was interesting that Guido was a member of that. He kind of was able to, I guess, get beyond some of the frustration that he had. He actually describes it as rage quitting. So the doc kind of wraps up around there, talking about maybe about 6 years ago, history-wise, which I thought was interesting, but now it makes a little more sense with the title that I mentioned. Generally, I enjoyed it. If you're interested in knowing a little more about where this language kind of started, where it came from, some of the players that were involved and are still involved, what are thoughts that you had about it, Chris?
There were a few surprises to me. There's a couple of folks in it, Paul Everett being one of them, who I've met and I've done a little bit of work with. I didn't realize just how far back his relationship with it was. Like,
he looks a little different in those early videos.
Well, that's fine. Everybody,
I know.
I am not one to point at getting older. That's that's. I managed to get older and fatter. He doesn't seem to have done that, so good for him. But no, I just didn't realize how involved he was in the early days, because I sort of know him from the PyCharm space. Similar, because I came to Python through the web side of things, I'm aware of the data sciencey stuff and I do a little bit with it, but I didn't realize how early it was having an influence. The relationship with Python sort of goes a little further back, but it was interesting. You mentioned up top that we designed this course, and it was an absolute accident. The course came about because there's a website that I use fairly frequently that has a list of what made it into what version of Python when. So if you're trying to decide, should I use the walrus operator? How far back does that go? What version would somebody use? Then you go, oh, okay, that's in this version. And I thought it would be kind of interesting just to sort of do like a history from a feature perspective. And while we're working on that, we found out about this documentary. And so it's interesting to sort of contrast between the two, because we've come at it very much from the feature, the language itself.
Yeah.
We touch on a little bit because there's things like, the 2 to 3 and the walrus operator have had big effects on the community. But for the most part, hey, this feature showed up here and this is the differences and this is that journey. So the documentary very much comes more from the social side of it and the people who are involved and how some of the decisions are made. It's easy to forget, given how old Python is, how unusual some of the things we take for granted are now. So like open source obviously predated Python, but the way open source is throughout everything. Like if you learn to program now, you are going to learn about open source's existence almost immediately.
Right.
Whereas it used to be this sort of a back room. You had to know what area on the BBS to log into in order to have those kinds of conversations. And so Python was very early on in a lot of this, right?
Yeah, definitely the 90s were an interesting time for that. This sort of right as the web is beginning and actually predating it slightly. And so, yeah, it's interesting to watch that. Yeah.
There were a couple conversations in there and you're commenting about the foundation and the, even just how the licenses changed over time. Well, we don't debate these things anymore, right? It's hey, there's 3 choices. Which one do you want? And everyone just picks one, right? Whereas that was during a time where those things were still being debated. And so, the license was being modified as they went along. So I don't know how much Python contributed to that, but they were definitely figuring out how to do things while everyone else was figuring this stuff out. And it's easy, once the path has been cleared, to forget that there were a bunch of guys with machetes who went out ahead of you to create the road.
Yeah, actually create a path. Yeah.
Yeah.
So yeah, our course, we're going through pretty much all the versions of Python, which is interesting. There's not a whole lot of detail we can cover. And version 1, I think we mentioned a bytecode article where he was standing up Python 1 and kind of going through it and some of the stuff that existed then. But we try to talk about, okay, what were some of the features that were added to the language, when they were introduced, and provide some code demonstrations of a lot of those. They're not super, super detailed. What we tried to do then is say, hey, instead of making this thing 17 hours long, here are additional resources about that particular features, because RePython has lots of tutorials. along with video courses that go with that. And I feel like one thing that you could get out of our course that is some of that later stuff that I mentioned, because both Chris and I and Real Python itself is of the last 6 years. And we've actually really gone pretty heavily into, partly through Gerarna being involved in writing these articles that were called like cool new features of Python 3.8 or whatever. And that tendency has continued. I created, I think, the Python 3.9 video course that was covering those features. And then you've taken over the last couple of years of doing those. So that's something where you can kind of get a nice overview of some of those things with a little more detail. And then we did a podcast almost every year. So we have lots of resources where you can kind of continue to learn even more on each one of these subjects if you want to dig into it. So that was kind of fun to cover.
And just a shout out to Ned Batchelder, because it was his website that sort of inspired us to do this. So, thanks for that page. I use it all the time. And thanks for inspiring us to create the course.
Yeah, the feedback so far has been good. Gotten a few comments already, and they said that they wanted more detail, and we're happy that there was more detail connected that they could dig into. Yeah, because there's so many of these features that have come along and enhanced the language in interesting ways. And we did our best to cover them in, again, a historical way. So yeah, I'm happy to see the reactions also about the documentary. So that's actually been really cool to see, people in the community talking about it. It's always kind of fun to do a little bit of that sort of like community building through discussing the past.
Well, and, as we've discussed recently, a significant percentage of people to Python are new to Python.
Yes,
so a little bit of history sometimes gives you, why does it do it that way? Oh, well, do I have a story for you?
Exactly. Yeah. Let me guess. Your time series queries start fast, then begin to crawl as data grows. Traditional databases weren't built for timestamp data like metrics, events, or sensor readings. They crash on high-volume writes and time-based queries. InfluxDB was purpose-built for this. Millions of data points per second, automatic compression, sub-10 millisecond queries. It's like choosing the right Python data structure. Using a list when you need a set works, but it's not optimal. Time series data deserves a time series database. Visit influxdata.com/realpython. So what do you got for your first topic?
Well, coincidentally, speaking of Ned Batchelder, we've got an article from him titled Regex Affordances. It's about a couple of Python features that can make dealing with regular expressions a little clearer. The article isn't so much on regexes themselves, but things that go with them. And like with a lot of Ned's stuff, it's got a good practical example to show you exactly what he's talking about. The first feature he demonstrates is verbose syntax. This is one of my favorites. This is a flag you can use in a Python regex that makes it ignore white space. So Ned's code uses parentheses $X to turn this on. I personally tend to just use it as there's a flag for the regex compiler, but so you've got choice. But why would you want to ignore white space in a regex? Well, this allows you to use multi-line strings, which means you can separate out the different parts of a regex. And since Python supports comment characters in regex, you can put a comment on each line so that when you come back to your code and go, what does that gibberish mean? You can remind yourself what that gibberish means. The second feature in the article is named groups. Regexes support ways of grouping matches, which can be named or unnamed. If they're unnamed, you get at them through a number, but in the named form, you can access them through a name, which is a bit more readable. For example, parentheses, capital P specifies a named capture, and then you put the name that you're capturing it into in angle brackets. This is then followed by whatever the regex is that you're matching. So if you're looking for a word with \W+, you could name that capture word inside of your match object in order to work with it. The example in the article uses the sub function in the RE module, which is all about substituting one value for another. It typically takes 3 arguments. It supports more, but 3 are what's needed. The first is the regex pattern. The second is the replacement string when a match is found. And the third is the text that you're actually operating on. The third feature in the article is about that replacement bit. Something I didn't realize is that instead of providing replacement text, you can provide a reference to a function. If you do that, your function gets called for each bit being replaced. This is pretty powerful as it allows you to make choices about what to do when a match is found. So this is something I'm going to keep in mind for later. It's not a terribly long article, but there's some good stuff here. The best part is it's real code. This isn't just an example. Ned is the maintainer of the coverage.py library, and the examples in the article are actually from that code base. And at the end of the article, he provides a link so you can actually see them in context if you're interested. So cool stuff.
Yeah, it's funny because you seem to be the regex person here at Real Python. You've done a couple different courses about it, and
I am so not.
I know it's not your favorite thing, but it's such a tool that you come up and need from time to time, and the ability to have a function tied to that is really interesting to me. That it adds this really nice flexibility.
Yeah. And in the example, he actually uses multiple different kinds of matches. And then inside of the function, you can see which kind of match it was. And then you can change which kind of substitution you have based on what kind of match it was. So yeah, it's a nifty little thing.
And I want to mention the name of the article from before that we were mentioning. It's titled "What's in Which Python," which is a good name, which says created in May of 2022, but last updated in August of this year. So I'm sure he's just constantly updating things. Lots and lots of links in there also. So a good resource. Yeah. Speaking of resources, one of the things that I've been interested in for a long time is how our listeners and beginners and people starting with Python can stand up their projects and share them with the world. A lot has changed since the time of me starting doing the show. A lot of it has to do with the world and how financing is happening and so forth, free money and that free tier then of things that have been sort of VC backed have disappeared from a lot of places. We used to suggest lots of different choices here. So I was kind of on the lookout of like, okay, well, what's going on as far as like hosting applications. So this is from a blog post by Jeff Morehouse on the Judo Scale website. It's titled "Where to Host Your Python App." Quick note, Judo Scale is like an auto scaling service that works with a few of the services that are mentioned. It does like metrics and a few other services. So I think that's partly why they created this piece to talk a little bit about how some of that would integrate, at least link to that. As I was saying, it's been a little bit leaner time over the last couple of years. Many of the free services and the free tiers have disappeared. So it's a bit tougher to suggest some resources where anybody's like learning the applications and just wants to experiment might rack up a large hosting bill. What I liked about this piece is they included a calculator to kind of show you what the scale of this stuff might be. So they have actually 4 different services that you can kind of do a little bit of calculations to determine. Most of them are geared toward larger projects, not as much for individual projects. But I liked some of the details in it. They talk about like, okay, well, you need to focus on how do you want to organize your application. A common way to do that is using Docker today because of the portability of it, the ability to create this virtual, if you will, container that is run inside a virtual machine and hosted in that way. You are unfortunately on the hook yourself then for a lot of things. You have to choose your OS, you have to choose your version of Python, you have to choose all the different resources, and you really build all of that inside there and then sort of close the doors on the container and then can ship it to some place to host it, which is interesting. And, you know, I've talked about Docker off and on the show. They contrast that with a tool like Heroku, which is very different. Heroku is more about you've created this project and you want to be able to simply do like a git push. And Heroku then will look at that and stand it up. It will find the version of the OS. It will look for what are the different packages and install that. They have this thing called a build pack. So it's a kind of a different structure of way of doing it. One note, Heroku was one of the go-to choices for free hosting for a long time, and then they've kind of changed the way they do things. They still have some fairly inexpensive plans. Real Python is run on Heroku, and we have had pretty good luck with it generally. So I think it's a nice, stable service. And once you got your initial push, it detects again the language and the needed dependencies. It's a good host for those types of things. So they talk about Heroku. They give some details there. They talk about two other services that are kind of similar. One is called Render. They consider it a cheaper Heroku style alternative. They offer another one called Fly.io, which they consider to be usually the cheapest choice. Again, these are just things that just kind of bounce through and cover a little bit of each of them. I'll let you go into the details, but they mention ECS, which is the Elastic Container Service on AWS. If you would like a deep dive on that, Calvin Hendricks Parker was on recently talking about scaling applications using Kubernetes and other things and AWS kind of focused stuff, which is pretty common for the company he works for, 6 Feet Up. He also then mentions what he likes to call self-hosting, which is sort of renting a server, if you will, or a virtual machine. This is something like DigitalOcean with their droplet architecture, or Hetzner or Linode. In those particular cases, you're basically logging into this other machine and doing a lot of the steps that are similar to Docker in the sense that you're, choosing the OS, you're choosing versions of Python and all your different dependencies and so forth. But it's then a machine that's running out there that's separate. And then the last section talks about their services, this idea of like, hey, as your traffic is growing, your business is growing, what can auto scaling help you with, and some of the details there. They have this nice calculator that's connected to that. Again, it compares Railway, Heroku, Render, and Fly. So I decided to look around a little bit more. I found another piece that covered this, but unfortunately, it's a little old. It's from December of 2022. That was the time when some of these things were still available, and a handful of the services are no longer on there. But I liked the general just sort of overview that's provided by this. It's by Patrick Lober, and it's titled Best Hosting Platforms for Python Applications and Python Scripts. It has a companion YouTube video. And again, this is right about when some of these pricing changes and things started to disappear. I'll mention some of the free providers that were included in there. Python Anywhere is still around, which is a really good service for this. It's now owned by Anaconda. It still has a free option for you to do experiments on. It, I think, has been tied to like the Django Girls projects and stuff like that as a nice way to get in and stand up your first Django project and so forth. Replit, which is interesting because it's more like a IDE, but it still does have a starter level. It's a great way to sort of share code and do experiments live. I guess you can host kind of simple apps on it, but they all remain sort of public. GitHub is still free, but it's more of an idea that if you want to do like a static site or something like that, it might be a good choice. It's really not for hosting an application. They mentioned Render also. It does have a hobby plan still, and I want to explore that a little bit more. One that isn't mentioned in either of these pieces is Anvil. Anvil has a free plan. It's a very interesting platform. I've had Meridiv Luff on the show back in episode 63 to talk specifically about Anvil, but it's a nice resource there if you want to do some experiments. And all of these services, obviously, you can scale upward into the paid tiers depending on what kind of resources you need. Hopefully, this will give you some resources for this. I'm always looking for more information. It was one of the few times where the Google AI overview was actually pretty good and actually had a lot of good resources. It did a decent survey of like, okay, well, what's still out there? What do you use it for hosting, or have you suggested for that sort of stuff?
Yeah, I'm a fan of OpalStack.
Okay.
They're about like halfway between those two spaces. So you are able to log into the machine, but the Linux is already there. The different versions of Python are already there. And for certain kinds of applications, they have like a controlling dashboard that will install everything and hook it up to Nginx for you. So especially for things like Django, you basically say, yeah, give me a new Django project, and it sets up all the infrastructure, and then you just dump your code in there.
Like a template of sorts.
Yeah. So they're fixed cost, right? So you pay for a access to a shared machine, or it scales. But for the vast majority of work I've done, it hasn't blown up and become thousands of users per second. And so an inexpensive, static, well-known thing where the price isn't going to fluctuate is kind of useful. So
Yeah.
yeah, it tends to be where I start. And then if my client happens to get lucky after that, then we'll talk about how to make it more complicated.
Yeah. Cool. Thanks. It's time to shine a spotlight on another Real Python video course. And it's about the one we discussed earlier in the episode. It's titled A History of Python Versions and Features. It's a code conversation between Christopher Trudeau and myself. The video course is a practical overview of how Python has evolved, features that changed in each major version, why it matters, and how to use the features that define modern Python. You'll see both the historical context and hands-on code, so you understand not just what changed, but why and how to use it today. We cover key new features introduced in every major Python version, starting from early Python 1 up to Python 3.14. The story behind pivotal changes like list comprehensions, exception handling, the with statement, and the transition from Python 2 to Python 3. Hands-on use of modern Python tools like f-strings, data classes, the walrus operator, match case structural pattern matching, and new data types like enum, and features like pathlib. How to leverage improvements in each Python release for cleaner, faster, and more maintainable code, along with what's coming in the latest Python release, including t-strings and REPL improvements. Real Python video courses are broken into easily consumable sections, and where needed, include code examples for the techniques shown. All lessons have a transcript, including closed captions. Check out the video course. You can find a link in the show notes, or you can find it using the search tool on realpython.com. All right, what do you got next?
My next article is by Itamar Turner-Trauing, who we've frequently talked about in the show. A lot of Itamar's articles are on performance. His blog is named Python Speed, after all, and this one's no different. The title is 330 times faster, 4 different ways to speed up your code. The premise is that performance boosts come from a variety of different practices, and sometimes those practices can be chained together. The example code that he optimizes is a letter counter. So Itamar wants to know how many of each letter of the alphabet shows up in a Jane Austen novel. The first version of the code loops through each letter in the text, storing its count in a dictionary. The code uses default dict from collections to avoid having to check if the letter's been seen before, uses isAlpha to make sure you're only counting letters, and uses lower so that the capital letters and the lower ones get counted as equivalents. Once the dictionary has been created, the code then sorts everything and spits out a list. Not surprisingly, for any Scrabble players out there, the most common letter is E, with over 44,000 appearances, which is 14,000 more than T, which is the second most common letter. All right, so now for the performance part. First off, you need to measure the code's speed so you can determine if any changes you make are actually improvements. Itamar uses the line profiler tool in order to spec that out. I mentioned that the article talks about a series of practices. Well, the first practice is efficiency. How can you do less work to get the same results? So examining the results of the profiler shows that a lot of the time is being spent in that call to lower that I mentioned. It's in the inner part of the loop, and it's getting called on all of the lowercase letters, which, of course, isn't necessary. So a new version of the code just counts all of the letters, putting them in a dictionary, and then does some post-processing to create a new dictionary, merging the capital and lower letter counts. This removes the call to lower from the long inner loop that is what is actually going over the text. Instead of replacing the original code, Itamar puts the new version in a new function, thus allowing you to compare the results between the two and make sure that your new algorithm isn't mucking things up. This improved version actually gives a 25% speed up, but his efficiency practice is not done. He creates a third version, which instead of using a dict, uses a list for storage in an attempt to avoid the overhead cost of hashing. For this to work, certain assumptions need to be made. For example, the rare instances of an accented letter, there must be some French words in Jane Austen's novel, those are going to get ignored. This third approach gives a further 25% speed up. So we're starting to see some accumulation here. The next practice is compilation, switching to a faster language. This is a common approach in Python, which is why libraries like NumPy and Polars are so speedy. The otherwise slow parts are implemented in languages that are faster than Python. To distinguish between the practice of efficiency and the practice of compilation, Itamar implements all three versions of his counting function in both Python and Rust. Rust is significantly faster, but even in Rust, there's an order of magnitude difference between the dictionary-based approach and the list-based one. So you can even see that even with faster languages. In case you're curious, there's a 165 times speed up between the original Python and the list-based Rust approach. Yeah, that was times, not percent. So we've gone from here's a 25% improvement to 165 time improvement.
Yeah.
So that's quite a chunk. The next practice covered is parallelism. Up until now, the code's been running on a single core. This particular problem is trivially parallelizable as each piece of text is independent of the others, so you can split the novel up into chunks and then divide the work amongst your CPUs. Itamar uses the Rayon library in Rust to add parallelism, and this actually multiplies this speed up by another 2 times, giving that final 330. The last practice is what Itamar calls the practice of process. So far, the same text is being used to benchmark the code. To get the performance measure, the code is being called repeatedly, and the runtimes are then being averaged. The problem is that repeated calls means the cache is involved, and you might not actually be measuring the real performance. The article goes into some detail about how strings get represented between Python and Rust, and how that can mess this kind of stuff up. This practice is making sure you're not optimizing the wrong thing. So he goes through and talks about what you should be measuring and what kind of speed up you actually get when you take these things into account. I like articles like this. Rather than a simple, hey, don't stick things in an inner loop, it guides you through the journey of improvement, shows you how to stack those improvements as needed. And as always, Itamar writes some good stuff.
Yeah, I noticed that he's working on a book.
Yeah, he's been doing that for quite some time.
Yeah, he's compiling lots of examples.
I remember seeing, I think it was a year or two ago, it was like, oh, I hope that comes out soon. And it's still coming. So I feel that pain. I've been there.
Yeah. All right. Well, that takes us into projects. My project this week is an older project, but it's had some recent updates and resources added. It's called Beets, spelled like the vegetable, Beets, but it is a music library manager. It seems as though it's maybe 13 years or maybe a little bit older, but it's had some recent stuff. I've been getting back into my MP3 library, which is a mess. So this is a project I'm going to spend some more time with, and I'll possibly report back. Here's some of the potential. It catalogs your collection. It automatically improves metadata. It goes through this tool called Music Brains to be able to add all kinds of metadata, everything from album art, the lyrics, genres, tempos, levels, which I think is interesting. I guess, go through the 90s compression nightmare. Acoustic fingerprints, which I think is an interesting thing I might look a little bit more at. But it can not only Music Brains, which I mentioned with a Z, Discogs and Beatport, I guess, or other places that it can grab this sort of metadata from. It can transcode audio, so if you want it in a different format. Most of my stuff is in this Apple-y format because I was using iTunes for a lot of it. And anyway, so I'm looking at using this. It is pip installable. You can use pip or UV if you want. It's coming from PyPI. It's on GitHub. They include a nice getting started guide, FAQ, discussion board. In fact, the most recent blog is from the 20th of August this year, and it's titled A Guided Walkthrough. So it looks like they're still pretty involved, which is probably why it appeared in PyCoders. So yeah, Beets. I don't know if other people are out there thinking beyond just using a music service, because I have quite a bit of music, and I think about just disconnecting from the internet and listening to my music in some ways. The other project I want to mention, this was submitted to me from Bas Terwin. He's a software engineer at the University of Amsterdam, and I'll include the GitHub for this. It's called Memory Graph, but Chris also saw that it was also submitted again to PyCoders, which is great. It's sort of a teaching tool and debugging aid. It provides context about references, mutable data types, and shallow and deep copies in Python. For students, it helps provide these concepts with much more of a visual way of checking things out. It uses GraphViz, which if you're installing it locally, you'll need to add that. There's a quick intro video about the installation and use, and then another one demonstrating the concepts of mutability, which is much longer. The GitHub page goes deep into many of these concepts and includes code examples, along with the visualizations that the code examples create. Things like copying values of immutable types, copying a mix of mutable and immutable values, a call stack, circular doubly linked lists, that's hard to say, binary trees, much more details on how to use it with debuggers. So if these are concepts that you struggle with, or maybe you would like to teach someone else about or explain to other people, I think it could be useful. The website is memory-graph.com. Actually has a live version of it running. So that might be a great way to kind of just explore with it. It's using PyCoder, which is really nice to kind of get you up and running. So yeah, thanks, Boz, for sharing this. What do you got for a project?
My project this week is called Color, spelt with a U. Sorry, my American friends. It's from a group called colorscience.org, also spelt with U. But oddly enough, the group is partially funded by an American nonprofit, so I have no idea how that happened. Anyways, the library essentially does everything color, some of which I understand and some of which I've never heard of. It's very comprehensive. It has a whole load of transformations, color corrections, color blindness conversion, blackbody spectral computation, lightness, luminance, and way more. You can compare colors, look information up from images and other data sources, convert between different color models, and oh man, are there more of those than I thought. I know of a few of them, but the list just goes on forever. As well, you can modify your colors based on things like optical phenomena like scattering. So this library is not for the faint of heart. It's obviously written by and for people who know this space.
Science is in the name there.
Yeah. There are some links to some tutorials that introduce you to some of the concepts, but if you're not somewhat familiar with the ideas of color space, diving directly into the library might be problematic. That said, if you need to do something with color, I'd be very, very surprised if it isn't here. It's got everything. So if this is where you work, this is something worth checking out.
I'm still scrolling the GitHub page.
It goes on forever. It goes on. There's like 4 pages of just color models. It's insane. Yeah.
Yeah, we're going way beyond RGB / CMYK / whatever. Yeah.
Yeah.
Cool. Yeah. Interesting. All right. Well, thanks for bringing all these articles and projects this week, Chris.
Glad to be here.
All right. Talk to you soon. And don't forget, if you're working with any timestamp data in your Python projects, you owe it to yourself to try the right tool for the job. InfluxDB makes time series data effortless. Whether you're building analytics dashboards, monitoring applications, or tracking performance metrics, join millions of developers who've already made the switch. Get started today at influxdata.com/realpython and see the difference the right database makes. I want to thank Christopher Trudeau for coming on the show again. And I want to thank you for listening to the Real Python podcast. Make sure that you click that follow button in your podcast player. And if you see a subscribe button somewhere, remember that the Real Python podcast is free. If you like the show, please leave us a review. You can find show notes with links to all the topics we spoke about inside your podcast player or at realpython.com/podcast. And while you're there, you can leave us a question or a topic idea. I've been your host, Christopher Bailey, and I look forward to talking to you soon.